Hi, welcome to GitMap. In this session, we will start using NLP. Specifically, we will use NLP with LDA to analyze topics in Enron email dataset. Enron email dataset is pretty popular dataset that has been used a lot in Kaggle competition. Topic modeling is a technique that looks for pattern in use of the words in emails. For computer, topic is a list of the words that happens in email in a statistical, meaningful way. Let's go ahead and get it started with topic modeling on Enron email dataset. We have Enron email dataset. Enron email dataset is related to the Enron company. This Enron company is well known for Enron scandal, which was an American energy-based company in Houston, Texas. Enron founded in 1985 and became the largest seller of the natural gas in North America by 1992. However, Enron's complex financial statements were confusing to shareholders for analysis and resulted in bankruptcy of Enron in 2001. And then the Enron email became open source and available to everyone, specifically for data scientists, data analysis, in order to make some analysis on them and see what was going on in Enron company. Here you would see three tabs. One, we're gonna do exploratory data analysis on this Enron email dataset. The second one is topic modeling. The third one is clustering. You can see the difference between topic modeling and clustering results, and based on your application, you might choose one. Let's go ahead and get it started with exploratory data analysis on Enron email dataset. As always, we start by importing the needed libraries and we read the dataset. In parentheses, the dataset that we're gonna use here is a smaller version of the actual dataset. We just got some fraction out of it because uploading the original dataset was not possible on the GitHub. That's why we chose a fraction in order to work with that and upload it on the GitHub. But full dataset is available from Kaggle and GitHub. You can download it and work on a real original dataset. We read this smaller dataset. This is how the dataset looks like. This is just one of the emails. You can see it has hashtags, email address, HTML link, and different parts such as message ID, subject, from, to. We need to make them a little bit organized. Good part of this email dataset is that all of these observations have message ID, from, to, subject, which might not be the case for the actual emails. That's why here we utilize the keys in order to extract those columns. However, that might not be possible for actual email datasets. We might need a little bit different methods in order to clean them up and create new columns. After creating the columns for content, from, to, user, the first part for exploratory data analysis is trying to figure out who sent most emails. We have the user column, we have the content, and utilizing these two, we can extract how many emails has sent by whom. And from results, you would see that Kaminsky has sent 913 emails with the subject, which has 4 words, and the content, which has 250 around words. This might be a good insight to investigate why this person has a lot of emails. The other important analysis was creating the network between senders and receivers of the emails. You will see that Peter Davis has sent 295 emails for the same person, which might be interesting to investigate why this was happening. And then we tried to use word cloud in order to see the words that are appearing in the subject and in the content more frequently than the others. You would see that on the subject part we have a meeting, sales issues, draft, presentation documents, and Enron deals. This is all related to some processes that were going on at the company. On the other side, however, we have the content. Using the word cloud, we couldn't get much on the content side. You can see these are not really meaningful because content has a lot of the words and it needs cleaning in order to extract the topics out of those contents, which we will do on next tab. So here, let's go ahead and get it started by importing libraries. And here is a little bit explanation about topic modeling with LDA. We already have the podcast. If you are interested, definitely listen to that. That explains clearly what's going on with the LDA. And we start by reading the small data set. Here is how the columns looks like from to subject and getting the process of the text. We have also the content part, which try to extract the words from that and also make it as a list. You can see how the words look like. Still, we need a little bit more cleanup, such as getting the engrams. You can extract bigrams or trigrams. Here, we try to extract the bigrams. For example, Enron email, which consistently go together. That's why we want to keep it as an Enron email rather than separating it as an Enron and email. That's why we utilize bigram here. And then we use stop words with some extension of the words that we see frequently are appearing in these texts. We try to remove those meaningless stop words. And also we try to extract lemma using the spacey, which only extract the noun, adjective, verb, and adverb. We try to use lemmatization to restrict the word to the base. We didn't use stemming because that was not much useful compared to lemmatization. And the last part of pre-processing was extracting the words that are more than 2 length, because we are looking for a meaningful word. That's why we try to keep the words that the length of them is more than 2. And finally, here is all of these functions going under the process, and then we utilize dictionary to extract the frequency of the words happening in the context. For example, energy was appearing 8,000 times, which makes sense because Enron was energy-based company. And now it's time for modeling. In order to do the modeling, we have the words ready, but we need to make it numeric. That's why we try to utilize dictionary and document to bag of words to create the corpus of that. And finally, apply LDA model from GenSim library on these corpus. Here are the generated topics, which each value shows how important that token is in that specific topic. This might seem a little bit messy, but we will clear things up. But this is more detailed information about topics and the keywords that are appearing in each topic. Okay, why we choose 20 here as a number of the topics? Actually, we did model perplexity and coherence. Model perplexity is basically measurement of how well a probability distribution predicts sample. If we have a lower number, that would be better for our purpose. And on the other hand, the higher coherence would imply that result is more human interpretable. So comparing these two values for different number of the topics could give you an idea about how many topics would be better for your topic modeling. Of course, there are some other methods, but this was the most meaningful and selected way. And finally, here you would see the 20 topics. Each topic has 15 words. The first topic is related to energy price transaction. The second one is California company, and the third one is communication, sending the message. So you can see how these topics are appearing in emails based on different generated keywords. And finally, here are the visualization of those topics. Basically, the size of the bubble shows how dominant that topic is across all of the documents or the corpus. Each closer bubbles to each other means that they are overlapping. It's better not to have these overlapping bubbles, but here we kept the 20 number of the topics. That's why this is appearing. So the other part is, as I said, comparing the values of the coherence for different number of the topics. You would see that 20 is the best, and then it changes a little bit and then goes down. That's why we kept with 20 the coherence value of 57, which is close to 58. And finally, we wanted to clean it up and put it as a one table. So here you would see original text of the email, keywords, and then the generated keywords for the topic, and the number of the document that is related to that exact email, the dominant topic, and the topic percent communication. Using this table, for each of the emails, you can get the keywords, the dominant topic, and all details related to that specific emails. One more thing is that you can identify topics on each email, such that using this little bit programming of coloring those keywords in that email, you would see, for example, on number 10 of the text file, we have topic 9, 26% contributing, topic 14, 26%, topic 7, 12% contributing in that specific emails. And also you can see the highlighted words that are related to each topic. Okay. That was topic modeling and how it works. Now let's move on to clustering. In clustering, again, we start by importing the libraries and trying to extract from two subject, and then try to clean up the content in different way. We try to use the regex in order to substitute some of the extra alphabets with the just empty space and clean up the words and get rid of the stop words. And finally, this is how the cleaned text looks like. And then we utilize TF-IDF vectorizer in order to transform the content to TF-IDF vectors and finally get the features from that and create TF selected words, and then utilize different models in order to do the clustering. So here specifically we utilized NMF factorization, which stands for non-negative matrix factorization, which is a group of the algorithm in multivariate analysis and linear algebra, where a matrix V is factorized into two matrices of W and H. It has the property that all of these three matrices have non-negative elements. That's why it is a non-negative matrix factorization. And in some way, you can see that it is similar to PCA, which goes by singular vector decomposition and eigenvalue and eigenvectors. Anyhow, let's go back for clustering. Utilizing NMF, considering the number of the clusters to be 20, you can see the words that are appearing in each cluster. And here you can see also we have used k-means clustering and assigned the cluster to each text, to each email. And you can see the number of the cluster and the email that is assigned to that cluster. And cluster 8 basically is related to help business, know it, take well, think, and like. And finally, here is the distribution of the emails that are included in each cluster. So main difference between clustering and topic modeling is that in topic modeling, it is more generative approach. However, in clustering, it is trying to cluster similar emails in one cluster. That's why the distribution is skewed when we are trying to sort them based on the number of the emails that are in different clusters. That's why topic modeling is preferred. Also, the other reason is that in clustering, you can see that you are not creating new topics. Basically, you are using whatever is inside the email and trying to put together those that are similar to each other. So I would say cluster 0 and topic 0 are totally different, and you would see that topic 0 was more meaningful than cluster 0. But based on your application, you might choose clustering rather than topic modeling. Okay, in order to make this clustering a little bit more meaningful, we can extract top words for each cluster. And the other way is just visualizing each cluster based on IDF score. So here I just selected 7 clusters in order to show you how it looks like, the words in each cluster, and try to get the top words. After selecting the top words for each cluster, you can see that for cluster 0, we have, think, also business, back, and then cluster 1, question, information, Enron, attached, and so on and so forth for different clusters until cluster 19, which overall we have 20 clusters. So this was our first exposure to unsupervised learning, specifically topic modeling and clustering. Both of them are unsupervised learning. We did not have any label data. Based on your application, you can select one and go with one, but at least for our application here, I would recommend topic modeling for topic modeling for Enron email dataset and extracting the topics from those emails. Rather than going for clustering, basically you can compare the result and choose one based on your interest and your application. Okay, thank you and talk to you later.